So hey everyone, I'm Raghav, and in this video we will talk about the four problems of the Leetcode Contest 387. So here is the first problem of the contest. Distribute elements into two arrays. In the problem it says that we have been given an integer array with all distinct elements. It is a one based array, and we need to distribute all the elements of nums array between the two arrays arr1 and arr2 using n operations. In the first operation, like from these n operations, in the first operation we will append the first element to the first array, the second element to the second array, and after that, for each and every operation afterwards, we will say that hey, in case if arr1, the last element of arr1 is greater than the last element of arr2, then append that current element, that is nums of I, to arr1. Otherwise append nums of I to arr2. Basically just append it to the array which is having the larger element at the end, and after that the result is the concatenation of both of these arrays. So in case if ARR1 at the end look like this and ARR2 look like this, just imagine if it look like these, this is how they looked, then result will be this thing. That is nothing but the concatenation of 1, 2, 3 and 4, 5, 6. And we will have to return the result. So I hope that the problem is clear. Now in this problem, you don't really have to do anything different. We just have to do the exact same thing which the problem has asked us to do. So like it is not really having any optimizations through logic. It is just a simple pure implementation of what we have been told to do. By the way, there is one, I can show you one try run before that. Let us talk about the case 213. Maybe this one or 213. Let's take 213 first. So if you have okay, just 1 minute, it's not connected. Yeah, I'm back. Okay, so let us take if the nums array look like 231, I guess. Yeah, 213. 213. Okay. So in that case, initially in ARR1 you will push 2, and in ARR2 you will push 1. Now for this 3, the larger element at the back is just 2, है ना? Like the last element of ARR1, that is 2, is greater than the last element of ARR2. So you will just push 3 at the back. That's it. After this, there are no more elements. So ARR1 is 2, 3 and ARR2 is 1. Concatenation will come out to be 2, 3, 1. Let me take the second example also. 5, 4, 3, 8. If nums array look like 5, 4, 3, 8, then initially ARR1 and ARR2 are empty. You will push the first element in the first array, the second element in the second array. It's 4. After that, the last element of ARR1 is greater than the last element of ARR2. So you will push this current element, that is 3, to ARR1 since it is having the larger element at the back. After this, the larger element, like the last element of ARR1 is 3 and the last element of ARR2 is 4. So this one is greater. We will push 8 here, the next element. And after that we don't really have any more elements, so that is the final values of ARR1 and ARR2. Now concatenating them will give us 5, 3, 4, 8, right? So that's our output. Now we just have to implement the exact same thing. So what we can do is we can just first of all create ARR1 and ARR2, right? From the logic, let's see how to think about the code. So first of all, we will just create two arrays ARR1 and ARR2 and push the first two elements in both of these arrays. After that, we will run up a for loop for all the elements from this, that is the third element, or you can, if you are having zero based indexing, then from I equal to 2. From there, you will have a for loop. Every time you will just compare the last two elements, sorry, not here, but the last two elements of the two arrays, and whichever is larger, with the help of if else conditions, we can just push the current element into that array. And at the end, we will just concatenate them. For concatenating them, like either you can use some STL function, or you can just create a new array with a new vector with name answer, and in them, and inside it, just insert all the elements of the first array, then insert all the elements of the second array. And now this is how you can concatenate it. So I think that the logic is already clear, and the way of implementation should also be clear. So probably first of all, you should pause the video here and go on and try to implement it on your own. After that, like I'm assuming that you have already tried. So here is how I did it. We have been given this nums array, है ना? So first of all, I'm finding its size. After that, I created two arrays, ARR1 and ARR2, and pushed up the first two elements in these two arrays. Then I went up with a for loop of starting from n, sorry, starting from 2 and going on till n minus 1, that is I is less than n. And every time I'm just comparing the last two elements of the arrays, sorry, of the vectors or arrays, like whatever you want to consider, and like whatever you want to say. Obviously, this is a vector, but people just call it as array also. Whatever. We will just push this in the end of the at the end of that vector, and after that, for concatenating, I have written three lines. If you want, you could have just written up it in one line by some STL function. But for simplicity, you can write three lines also. Okay, so I believe that it should be clear. Looking up at the time and space complexities, we have declared two arrays which at the end of the day, after the complete loops, the total number of elements in both of these combined would be n. Basically, all these elements are being placed in either one of them. So at the end, we are having big of n space being taken by these two, and big O of n space being taken by this array answer. So we have uh, like we can say that we have used big O of n space in general. And similarly for time complexity also, we are just running up, like in apart from initializations, we are just running up our big of n uh, loop, and here also it is combined big of n, and inside the loops these are just big of one function. So overall time is also big of n, though it's not actually big of n, it is a bit different, because if you are having an array being initialized with size 0 and you push up n elements, at the end it actually turns out to be n log n, as much as I know, but we generally ignore that. We just consider it to be big of n whenever we are just pushing it. You know, at the basic level, we don't really need to worry that much, and the constraints are very small, so uh, that's also not a problem. Okay, so let's move on to the second problem. Count submatrices with top left element and sum less than k. In this problem, we have been told that there is a zero indexed integer matrix grid and an integer k. Return the number of submatrices that contain top left element of the grid and have a sum less than equal to k. So it says that we have been given a matrix, or you can call it as a grid, like whatever you want to say. We have been given a matrix, let us say, or maybe I can have a little border pen. Yeah. It has, let us say that it has n rows and m columns. So what it says is you have to find out the number of submatrices such that top left element should it should start with the top left element. Basically it should start with 1 comma 1 or 0 comma 0 in case of zero based indexing. It should start with the top left element है ना. And the second constraint is that the sum of let's say if you talk about this matrix which is starting from row and which is starting from row 0 till let's say row, sorry, yeah, it is starting with row 0. Let us say it is going on till row I, starting on with column 0 and going on till column j. Basically the first element is 0 comma 0 and the last element is I comma j. So let me denote the sum of all elements in this submatrix as sum of I comma j. Like I will just say sum of ij. By that what I mean is, like every time I say this thing, I just mean to say the denote the sum of all the elements in this submatrix which is having the first starting point at 0 0, that is the row 0 and column 0, and it is going on till row I and column j. So all the elements in this range, for all of them I will denote the sum with sum I comma j. So what I want is, the first thing is it should start with 0 comma 0 and some ij should be less than equal to k. K is an integer being given to us along with the grid. So I hope that the problem is clear. We just have to find out how many submatrices which satisfy these conditions are there in this grid, given grid. So um, let us do one more thing. Let us see the constraints. Here, uh, by the way, in the problem, they have actually considered m rows and n be the number of columns. But in the explanation, like what I have done is, I'm considering the number of rows as n and the number of columns as m. It doesn't really matter. It is just a different way of like just giving different variable names. And one thing being given to us is that n and m are less than equal to 1000. First of all, ask yourself how many submatrices are there. How many submatrices will be there such that they satisfy this condition at the least. Like for this condition, you would require to know about the sum of all elements, but at the very least, this is giving you some constraint over the starting point. है ना? In general, like this thing which I'm going to discuss right now is not really related to the current problem, but actually it is related to submatrices in general. In a matrix with n rows and m columns, how will you tell your let's say you have to tell one of your friends about a submatrix. So how will you tell it? You will just tell him that, hey, you are talking about the submatrix which is having maybe 2, maybe the starting row is 2, like a value can be anything. Let us say if it is 2, so you will tell him about the starting row, you will tell him about the ending row, basically the last row, है ना? And similarly you will tell him about the first column and the last column, right? You will tell him about these 4 things. So, and one more thing, if you see, for a specific value of starting row, ending value can have any of these, like any of these could have been the case. And for the, let's say if this is the starting column, then all of these columns could have been the ending column. So like what I mean to say basically is that all of these rows and columns are kind of independent on each other. Or maybe just consider this part, that if you have to choose 2 rows as starting and ending rows, there are nc2 number of possible combinations. Similarly for columns there are MC2 combinations. So in general you can say that there will be n square into m square, somewhat like these many submatrices in a complete matrix in order of n square plus m square into m square, not exactly this amount but in order of that है ना. If you talk about the exact number, it should be I think it should be nc2 into mc2. ठीक है. So we see that there can be a lot of matrices. Right now we are not really talking about the problem, we are talking about general stuff. Now if I say that the first point is fixed, starting and ending, starting row and starting column are being fixed, so in that case you have only these 2 points, like these two things which can change. In the problem we have there, the starting row is fixed to 0 and starting column is also fixed to 0. So the only choice you have is for the ending row and ending column है ना. So basically from there I hope that you got the point that there will be n into m number of possible combinations of the ending row and ending column. That is the number of submatrices we will have which satisfy the constraint one, like which satisfy this constraint, this one. We have not checked out for the second constraint yet है ना, which start from 0 comma 0. Now if you could somehow find out, okay, let me draw one more grid now. Now we know that our grid will definitely like start from here, and you only have to consider, like you just want to find out the sum of I comma j for all I and j. That's what you want to find out, right? And for j also, that's what we want to find out. I think that it should be clear till now. Now if we find out this thing for all of I and j, why are we finding it? Because we know that the number of submatrices, that is n into m, is not really that huge. This thing can be as huge as 10 raised to the power 6 because n and m are as large as 10 raised to the power 3 in themselves. So overall n into m can be as large as 10 raised to the power 6. We can store this information for each and every submatrix, right? But the deal is, how will you find out the sum of all the submatrices starting from 0 comma 0? Now this thing is kind of standard. This is a standard technique. I will directly tell you about the technique now. So what we do is, let us say if you want to find out sum of I comma j here, then you want to know about the sum of all of these elements. You know about the current element. है ना? Let me draw a, basically let me just remove this thing and this thing. Yeah. So you know about this element yet, right? You want to know about all these other elements. If you look at this guy, it knows about all of these elements here. Let me use a bolder pen, specifically bolder here. This blue guy knows about all these elements. Similarly, there is another guy who knows about these elements, right? So green knows about these, blue knows about these. You got, I think that you have already got the idea. You know about the current element already. You can ask green for all these elements, blue for these elements, but there are some elements which have been repeated in both blue and green, so you have to subtract this area. And this red guy, sorry, yeah, this red guy knows about, I didn't mean to, okay, yeah, this red guy knows about the sum of all these elements in this area, right? So what you can do is, like, probably you have got the idea, I think. If you're talking about sum of I comma j, assuming that the name of this matrix is A, in the problem they have named it as grade, but in general, let's say if it is A, then sum of I comma j would be nothing but sum of, like, A of I plus j, aij, plus sum of I minus 1 j, plus sum of I and j minus 1, plus, sorry, not plus, but minus the red area, sum of I minus 1, j minus 1. So if you see, this is the white area, like the element which we already know about. This is the green area, the element on the left. This is the blue area, and this is the red area, right? This is a standard thing which you should know about. In case if you didn't know about it right now, it's not a problem, but try to remember this thing for future. It can be very handy. Uh, and with this thing, like, you don't really have to remember the formula or anything. You just need to remember the idea. From that idea you can easily derive it. Key, you just add up this, you have got some thing repeated twice, so just subtract it, है ना? Now you will have to, probably you have got a good idea and you can actually try out solving the problem on your own now. So maybe you should just go on about it, like, try to code it on code it on your own once, and after that come back in case if you are not able to solve it. So assuming that you have actually tried, now one problem you might have faced up is sum of I minus j might not really exist. What if I is equal to 0 and j is equal to 2? What if you are talking about maybe this element? In general, we know that for I comma j, this method will work, like this formula will work. But for something like I equal to 0 and j equal to 2, where, um, like, if you're talking about this guy, those two elements on the upside and up left does not really exist. So in that case, your sum of 0 comma 2 would be nothing but only this thing plus this thing, right? Similarly, if j was 0, in that case you would eliminate this thing and this thing, है ना? So like, from there on, like, you could have got that idea ki, uh, like, the thing is still the same, but the way of writing can be written in a little different way. The way I prefer is sum of ij being initialized with aij initially. After that I write a if condition that, hey, if I is greater than 0, then sum of I comma j, basically this is something you can create as a vector. I did create it as a vector. um, it's not actually a function, it's just a vector here. Like, it will store some information, and for now I'm just writing it as this, being like increment sum of I minus 1 j only when I is greater than 0. Similarly, if j is greater than 0, then increment sum of I and j minus 1. And if I is greater than 0 and j is greater than 0, only then subtract it, है ना? Either you can write it in this way, or you can just create a different function which will return 0 for something when you pass on negative parameters. It's up to you the way you want to implement it. The basic idea was this thing. Now coming back to the problem, the real problem. So we just saw that there are only n into m number of submatrices which does which can have this constraint over them. For all each and every one of them, I can just find out the sum of the submatrix. If that sum is greater than equal to k, then I can just maintain an integer with name answer. I will just increment it whenever this condition is being satisfied. And obviously I'm only considering these submatrices, so both of these constraints are being satisfied in that case, right? So let me show you my code. Here what I did is, first of all, just taking NNM, then I did create a vector of int with name sum of dimensions nm, basically the same dimensions as of grid, and an integer with name answer. Then I went up with two for loops, basically going on to each and every element in the matrix. There I did write up these four things which I discussed here just now, that hey, in case of sum of I, like initializing sum of ij as the current element, grade ij, then in case if I is greater than 0, then increment sum of I minus 1 j to some ij. If j is greater than 0, then increment sum of I j minus 1 to some ij. In case if I and j both are greater than 0, then that reduction part, this is the red part, so we will here subtract that, this guy, है ना? And after all of that, once we have actually found the sum of all the elements in the current matrix, we will um, actually check if this thing is actually less than or equal to k. If it is, then increment answer by 1. Now one thing you should be cautious here is, at the time when you are trying to find out sum of ij with the help of sum of I minus 1j or sum of ij minus 1 or this guy, all of these must be counted, like must have already got their results before some ij. This is something we study in DP, but you don't really need to um, complicate things with dynamic programming if you don't know about it. Um, Basically, for now, you can just, like, in case if you know about dynamic programming, you can have a better understanding of why we are going in this way only. But otherwise, you can just leave that part for now and just um, try to think about it with the way, with the knowledge you already have. Ki why are we going on in this way only like in this way, ki going on to all the cells of the first row, then all the cells of the second row, and all the cells of the third row, and so on. We are going in this way so that at any place you would have already calculated the elements of the previous row and the previous column of the same row also. And these are being already calculated. So this is why we are not having any problem here. But if you were trying to go in a way like m minus 1 to j is greater than equal to 0, there you will have a problem. In case if it looks confusing, there's no need to get tensed about it. Uh, for now, this much is enough, I think, for you. And yeah, at the end, we are just returning answer. So this problem is also done. The time complexity and space complexities here are, for creating this sum array, it will take big O of n into m time and space. After that, we are going on with the for loop. So it will overall take big O of n square time n into m time complexity, and this is the only space we have declared for us. So time and space, both of these things are big O of n square, n into m, right? Both of these are n into m, and that's it. So I hope that this problem is also clear. Let us look at the third problem. This one is a lot easier than what we expect for the third. B problem was a bit harder than what we expect for B, but C is easier than what we expect for C. In the C problem, yeah, in the C problem, what it says is we have been given a zero indexed n into n grid where n is odd, and grid of RC is one of the three elements, either 0, 1, or 2, and we say a cell belongs to the letter Y if it belongs to one of these three things. Basically, see that there will be a Y shape at the end. If you look at this, there is a Y shape with the zeros here. है ना? So if a cell belongs to any one of these three, that is the diagonal from the top left to the center, or the diagonal from the top right to the center, or the line, vertical line from the center to the center of the last row. If a cell belongs to any one of these three, then we call it as cell which belongs to letter y, and then we say that the letter y is written on the grid if and only if all the values which belong to the which are belonging to the y, all of those which belong to y are equal, all of those which does not belong to y are also equal, like in this case all the cells which belong to y are 0, all the other cells are 2, and the values at the cells belonging to y and the values of the cells which are not belonging to y are different. So just imagine if all the elements were 0, in that case the first two conditions would be true, but it won't really create a y, है ना? If you maybe like I can just discuss the whole thing again. We are having a grid with n into n size, n rows and columns. It will have elements from either 0, 1 and 2. We call something like a y if let me just create a grid once. 1, 2, 3, 4. Okay, so we call something like a y if this this shape is being created. So all of these elements must be equal. This is the first condition. All y cells should be equal, should have same value. All the other cells should have a different value. Let's say all of them are having a value 1. They can have any value, but it should be something different from the thing you had in the first way. So the second is all others should also have same, like all non-y cells should also have same value, and the values which y cells have should not be equal to the values which non-y cells have. Values of y cell and non-y cells should be different. Right, these are the only three conditions we have, and we have to tell the minimum number of operations needed to write the letter y on the grid, given that in one operation you can change the values to any one of the cells, like at any cell to any one of the three things, 0, 1 or 2. Here the value of n is very small, which and the grid can have only three kind of values and n is odd. Now there is a question from my side to you. Why do you think the problem explicitly said that y, like sorry, n will definitely be odd? Try to think about it, pause the video and try to think about it. So the answer here is simple. Let us say if you have a grid like this one of size n into n, which is 4 into 4, then there is no center cell. First of all, there is no center cell. Basically, you will not be able to have a y shape, है ना? You might just say, yeah, I can consider this as a y shape, but like it won't be the thing which the problem wants us. So they have just created some simpler stuff for us by taking n as odd. Problem setter could have actually taken n as even also and made some different constraints over the y cells and made things worse for us, but it's fine. So here you just required one simple observation, that out of these three colors, one of them will be the color for the y cell, and out of these three, other than the one which you have already chosen for this guy, one of these two will be the color for the non-y cell, because the y cell and non-y cell should have different colors. So you have three choices for, like, not color but actually value. You have three choices for having the value at y cells, three choices of values, like either you can have the y cells with just ones or twos or threes, and then you will have two choices remaining for the other case, right? That is the case. You have three choices for having y cells or and two choices for having non-y cells. Now if I say, now let us say I have been given a grid, maybe I can take up this example: 1 2 2, 1 2 2, 1 1 0, 1 1 0, 0 1 0, 0 1 0. In a case like this, let us say I decide, yeah, I will take 1 as the y cell, like for all the y cells I will take 1 as the value, and for all the non y cells I decided to have 0. Let us say I think about something like this. In that case, I know that at the end of the day, my matrix should look like 1, 1, 1, 1, and all the others are zeros. Right? That's it. I know how my grid initially looks. I know how my grid I want it to look like. So, can I find out the cost? Like, can I find out how many operations I need to apply on this thing to create it like this? Yes, exactly. I can just look up for the things which are different. है ना? The cells which are different. I can just find out those different cells. That would be my cost. I can do the exact same thing for the other combinations also. Like there can be a combination where you take two as the Y cell and one as the background. Let me call let me call these Y cells as the primary cells. Let me call these things as the primary cells and these as the secondary cells. So if I know about, in general, I can say that if I know about the number of rows and number of columns, basically I know about the value of n. I know that I will have some primary cells like these. Like my primary cells will be like these, and the secondary cells will come up like this. है ना? I know about this thing. So I can just say, yeah, initially say P would be equal to 1, S will be equal to 0. Then maybe like for the combinations of P comma S, you can have the values like 1 0, like having P as 1 and S is 0, or having P as 2, S is 0, or maybe the combination of 0 comma 1, 0 being primary and 1 being secondary. Similarly, 2 1 or 0 2 and 1 2. These are the only six combinations you can form of primary and secondary. For all of them, like for any cell, you can just check out if, like for any cell, you can just check out if it is a primary or secondary by just checking PR for any n. For any n, let us say if you have a cell I comma j and you want to check if it is primary or not, then you can just say, yeah, in case if the value of I, that is the row number, is greater than or equal to the mid one, the middle row. If it is belonging to this, then C must be equal to n by 2, right? If your row is greater than equal to the middle one, then the column must always be middle for the cell being primary. In the other case, when the row is actually less than or equal to this, basically it is lying in this case, then either the row number and column number should be same, or the column number should be n minus 1 minus row number. है ना? Basically for the zeroth row, the column should be n minus 1. For the row 1, column should be n minus 2. That is, you can say column should be equal to n minus 1 minus row number. है ना? Probably you got the idea of how to find out whether the cell is primary or secondary, since you would have already fixed some color or value for primary and secondary. You already know about the current value. You can just use these informations for finding out whether the cell is actually having the correct value, or you have to change the value. If you have to change the value, then you have to use an operation there. And for all of these, you can independently find out their costs. Whatever minimum cost you got, that is your answer, like the minimum cost of all of these. So I will recommend you to pause the video here and try to do this problem on your own. After that, you can come back and look at my code if you want. So I'm just showing it, assuming that you have already tried. What I did here is I created a function with the name get cost, which I'm running up. Like in the get cost, I will have three parameters: the grid, and the primary color and the secondary color, or basically primary value and the secondary value. Initially, I initialize my answer with n into n, assuming that I will just change the value of all the elements in the whole matrix. Basically, this is even worse than the worst case, so my answer, value of answer would definitely be changed at the end. And since I want the minimum value, so I'm always saying answer equal to min of answer and something. And there, initially I took get cost of the grid if 1 is the primary color and 0 is the secondary color. Then I said that what if 2 is the primary color and 0 is the secondary color, and so on for all the possible combinations. Now for finding out the cost of a combination where you have already determined some primary color and some secondary color, you can just simply say, yeah, iterate over the whole matrix. For every cell, just identify if this cell is primary and the grid is not equal to primary. Basically, see, if you know that the current cell is primary, it should have the value, primary value, the value p we have passed. So in case if it is not equal to p, then you will have to actually apply an operation. In the other case, if the current cell is not primary, which means that the cell is secondary, but the value of grid is not secondary, then again you will have to apply an operation to make the value equal to secondary. So cost would be incremented, which was initialized to 0, and you will just return the cost at the end. And for finding out whether a cell is primary or not, I just wrote these two conditions, that hey, in case if the row number is greater than equal to n by 2, basically it is the lower half, it is this lower half where you get the vertical line. In that case, the column number must be equal to n by 2. In case if both of these conditions hold true at the same time, then return true. Otherwise, I'm checking that hey, if the row number is less than equal to n by 2, like now I'm checking for the diagonals. In that case, either it should be this diagonal, that is this one, which is going from top left to the center. There, the column number is actually always equal to the row number, or the other diagonal, which is going from top right to the center. There, you will always have column number equal to n minus row minus 1. And you can actually figure this out on your own also, uh, by dry running also, that for row 0 column is n minus 1, row 1 column is n minus 2, row 3 column is n minus 3, and so on. So um, for row 2 column was n minus 3, basically column is always equal to n minus row minus 1. So in that case also we can return true, otherwise return false. And that's it for this problem. The complexity here will be like we are having this function being called 6 number of times. Every time this function is taking n square time complexity. So in general, we can just say the time complexity to be equal to n square. And for the space complexity, other than the grid we originally had, we just used some constant space everywhere. You know, we always just used some constant space. We did not really declare anything which was taking a lot of space. So it's a like auxiliary space complexity will be big O of 1, and the overall space complexity will be big O of n square, because we are actually having the grid. Um, Generally, we do tell about the auxiliary space complexity, so we will answer big O of 1 there. Right. Let us look at the fourth problem. The fourth problem is a bit different from the first problem. In the first problem we said that, hey, in case if the last element of the array 1 is greater than the last element of array 2, then we were appending nums I to array 1. But here we have a different thing. Here we have a function greater count, which such that if we get like this, give two parameters, array and the value to greater count, it will return us the number of elements in ARR that are strictly greater than value. The number of elements in this array which are strictly greater than the value. That is what it will return to us. And what we have to do is, like in the problem which we did, like the first problem which we did, everything is exactly same. The other thing is, the only difference is, instead of checking if the last value is greater than if the last value of first array is greater than the last value of second array, we will check if the number of values in the array 1 which are greater than the nums is, if that count is greater than the count of number of elements in array 2 which are greater than nums of I or not. So let me show this thing here also. Like verbally the problem might look a little vague. We have been given some nums array. It will have some elements. Now we will have two arrays, ARR1 and ARR2. Initially both of them will have the first two elements, like nums 0 and nums 1 will be there in these two arrays. After that, let's say that maybe I can just say, if the elements were 0 or maybe 1, 7, 2, 6, 9, something like this. So in this case, if you have something like a 1, just push it. The first element should be pushed at the ARR1. It has been told in the problem. The second element should be pushed in the second array. It has also been told to us. For the third element, we will check out how many elements are there in the array 1 which are greater than 2. You will get that there are no elements. In array 2, we have one element greater. So here we will get greater count of ARR1 comma this element that is 2 comes out to be 0. And the same thing, for now, instead of writing greater count again and again, I will just call it as GC, just to make things convenient for me while explaining. Like whenever I write GC, just understand that I'm writing greater count in short. Maybe I can say GCNT. So GCNT of array 2 comma 2, for array 2 there is one element greater than this, so it will come out to be 1. Now since this amount, like this count is great, like this thing is greater than this, so we will push this 2 into the second array. We pushed it, and maybe I can just let me make it 2 for now. The till now the problem would be same, like I just modified it for future. Now for the 7, like sorry, for the 6, how many elements in the first array are there which are greater than 6? There are still no elements which are greater than 6. In ARR2, again there are no elements which are greater than 6, so here also the count will be sorry, there is one element in ARR2 which is greater than 2, sorry, greater than 6, so the count will still be 1, and thus this element will be pushed up here. So you will get 7 to 6. This array is now 7 to 6 and this array is still 2. Now for the next element, how many elements are there? How many elements are there? I'm just dry running the problem right now for explanation purpose. How many elements are there in the array 1 which are greater than 9? There are no elements. How many elements are there in the second array which are greater than 9? Again, there are no elements. So what to do when there are, like the count comes out to be same? We read the first two lines that, hey, if greater count of ARR1 is greater than the greater count of ARR2 for ARR2, then we append the element to ARR1. In the other case, if greater count for 2 is greater, then we append it to ARR2. If both of them are equal, in that case, we will append nums of I to the array with lesser number of elements. Here in this case, ARR1 is having only one number of element. The size of ARR1 is 1 and it has 3. So we will push this 9 in this array. Let us say there was there were two nines, there were two more nines. Let me just like for taking out the other cases also, I'm just taking some arbitrary numbers for now, something like this. Now for the next 9, how many elements are there which are greater in ARR1 which are greater than 9? There are no elements. Similarly for ARR2, again the count will come out to be 0. So we will just push this 9 in the array with a smaller size. So we will push it here. Now both of these arrays are having a size of 3 and 3. For the next element, again the greater count is 0, greater count is equal for both of the cases. So we will push 9 in the, okay, yeah, sorry, 3. We will push nums of I to the array with lesser number of elements. But if there is still a tie, then we will push nums of I to the array 1. Since there was a tie here, we will push nums of I to the small, like to the array 1, and thus it would be pushed up here. After that, let's say we got 10, even if it was 9, it was the same thing. Like any value where greater count is clashing, where greater count is coming up to be the same in both of these cases, even if there is a 1 maybe, even if the element is 1, greater count in both of these comes out to be 3 and 3, right? Since both of these are having the same greater count, we will see their sizes. ARR2 is having a smaller size, so we will push 1 here, and that's it. We have covered all the elements. After that, we will just concatenate both of these as we did in the first problem. So it will become something like this, right? This will be our output for this kind of an input. Now let us okay, we have read the complete problem. Now we just have to identify what to do in this problem. Like one thing is clear, in the first problem, since we had to only compare the last two elements instead of this, it was something you could do it in big of one, right? But now finding out this greater count is the only task you have to do optimally. All the other process will take only big of n, है ना? Let us say um, maybe I will just show you. In the first problem, what we did was we said ARR1 is equal to nums of 1, sorry, nums of 0. Right now I'm taking nums in the 0 based indexing, and ARR2 is initially nums of 1. Then we were actually having a for loop, and inside that for loop, I was just comparing the largest two elements there. है ना? There I was just sorry, not largest two elements, but the last two elements. I was just comparing the last two elements. Here, what I have to do is I have to compare G count, like GCNT of ARR1 with let us say x is equal to nums of I here. Just instead of writing nums of I again and again, I will like write x here. So GCNT of ARR1x, if this thing is greater than GCNT of ARR2 of x, then we will insert or append to ARR1. Else if GCNT of ARR1 comma x is less than the GCNT of ARR2, then we will append to ARR2. Else if ARR1 dot size is less than ARR2 dot size, Then we will again append to ARR1 in this case also append to ARR1, and in the else condition we will append to ARR2, right? At the very least this thing should make sense. Like we have to figure out some other way, or like at the very least we will first of all try to see if we can optimally do this thing. In case if we cannot do this thing optimally, then we will look up for making some manipulating the problem a little bit. But the other things should be clear, that in case like you will try to compare the GCNT. If the GCNT comes up to be equal, in that case you will come up to this if else conditions, sorry, else if conditions. In the else condition you will say here, hey, if the size is less, then append to ARR1. Else if ARR1 dot size is greater than append to ARR2, and in case in the else condition if both of them are also equal, then you will append to ARR1, or you can just write it like this, that if the size is less than or equal to ARR1, then append it to ARR1, right? Now our only concern is how to find out this count of number of elements in an array with some number. It is like you want to maintain something, sorry, not like this. You want to perform some type of operations where you will have maybe some container, or basically any data structure in which you can insert some element, maybe you can insert nums of I, and after that you can give it a query which will ask which will have one element, maybe x, and it will return you from that query, it will return you count of elements that are greater than x, right? That is what you want. If you see, that's the only thing. Like you want to append some elements at some places, and after that you just want to have a query like this where you know about an element, sorry, you know about the array, and you would like to ask how many elements are there which are greater than some given element, है ना? So for this thing, for doing this very specific thing, like once you come up to this part, this thing is something standard. If you ever need a functionality like this one, you can either use an ordered set. This is something you might have studied, or you can just search about it on internet. Ordered set, it is a policy based data structure, and it is available in C++. I'm not really sure about other languages. I think it is not available in Java, and this is not really recommended a lot of times, like until and unless you are not having any other way. Many people recommend not to use this, and they recommend to use segment trees with coordinate compression if it is possible. Now these are the two standard techniques I would recommend you to study about. If you are a C++ user, you can study about ordered set and try to solve this problem with it. It will be submitted. It can be solved with ordered set. And in the other case, like after this, or for any person who is not in C++, you should study about this thing. This is an algorithm which will work in this problem, but sometimes it like uh, in the cases where you already know what elements can be pushed at last, like if you have some array, like you know about, maybe you already know what kind of elements would be pushed inside this set, or you know that any one of these elements would be pushed. There will be no element, like you will never have a different element from these which would be pushed. Maybe I think I should not really spend time at explaining this part right now. You will actually get to know about this once you study about segment trees with coordinate compression. CACS problem set is also having a problem on this. In the range queries section, you can actually solve a few problems on this with this topic as well. And once you will do it, you will realize that we can just do some coordinate compression for the given numbers. Something like, what do maybe, let us say if we have a set like 7 2 3 6 9. Let us say you are having a vector like an array of these elements, and at any place you don't really care about their actual values. You just care about whether this guy is smaller than this guy or not, whether to like whether the element on this place is smaller than the element on this place or not. If you only care about relations like these, only their uh, relative comparison of whether which element is greater, which element is smaller. If instead of this array I make it equal to something like 1 2 3 4 5, would it be the same thing? Like, you see, if I only care about whether this guy is smaller than this guy or not, this thing would still be the same. I just compressed this information which was actually having elements from the range in the range from 2 to 9 to elements in the range from 1 to 5. I just compressed this information from this. Let us say if this element was equal to 900. I'm not really explaining it properly right now. This is something standard and you can study about it. You will get a lot of resources online. CP algorithms or CSCS problem set, you will get many problems and a lot of things related to this. I'm just giving some overview. In a problem like this one, storing these elements at some place could have been a problem. Like if you wanted to store the count of 2, the count of 900, it will take up a lot of space there. But if you do the coordinate compression, if you just compress that data somehow, that one is like the smallest element being given a number 1, the second smallest element being given a number 2, the third smallest number being given a number 3, the fourth smallest number being given a number 4, the fifth smallest or basically the largest element being given the number 5. In this way, if you just compress the coordinates, now let us say you want to find out the value of the number of occurrences of 2. You can just say that, hey, please tell me the corresponding value in the new array I've created. Like this was the original array. Let's say you created this array somehow. Then you can just ask that, hey, go to this place. Like you can just store here for 2. What is the corresponding element? It is 1. Then, like, not even this, in this way we store it in a different way, but the basic idea is from 2 you can get the number we have given to it, and we could have created a count array of only the size equal to the number of elements in this array. So it would take only big O of n space, and for accessing this thing I can just say cnt of 1, है ना? Or actually anything. Basically you got the idea कि coordinate compression can be helpful. You can study about it more on your own. We just use that technique with segment trees. Now I'm not really gonna explain the whole stuff here, but what we do is, the basic idea is, if you have something like let us take a set like 2 7 4 6. This is if this is your nums array, you can just create an array A from it, which would be sorted. The indices for the elements would be 0 1 2 3. Like obviously we always have 0 based indexing in C++ and in most of the programming languages. Now if I want to find out the corresponding number, like for this 2 here I was giving 1, for 7 I was giving 4, like the corresponding number which I was giving, let us say I want to find out that thing for 4. I can just say that, hey, in this array find out the first occurrence of 4, find it out. After that, that index at which it is coming, which we can actually find out in log n time by using binary search, and in C++ we can just say lower bound, like just find out the iterator using lower bound minus a dot begin. है ना? In this way, you can actually find out the index in big O of 1, and you can store your information in the segment tree assuming that the elements were actually 0, 1, 2, 3. In the segment tree, you could have stored the information in that way. So you could have created a segment tree for the array A, where let us say let us say if I push this 4 into the array 1, then in the segment tree of array 1 at the index 1, I will make it equal to 1. Initially all the elements are 0. Initially all the elements will be 0. Let us say I update a value at some, maybe I say here 7 has been pushed into the array for which I have created the segment tree. So I can just say here, tell me about the index of 7, which I will get through lower bound minus a dot to begin, and I will get this 3. Once I get this 3, I will go on in the segment tree, and at the index 3 I will just update it to 1 now. And obviously a segment tree will not really look up like only like this. A segment tree will actually not even like this. A segment tree would be looking something like this, right? In any way you see. So with the help of the segment tree, we will be able to do our operations in login time per query. And for getting the indices, like for the normal elements, we have been coordinate compressing them. It is also taking login time every time whenever we want to find the index. So login time and then plus login time. Basically, in a login time overall, in big O of login time, we are able to add the elements. For adding the elements into the segment tree which we have created, it is taking login time. And what is the advantage of segment tree? If I want to know about the number of elements which are strictly greater than 2 in the segment tree, I can just raise up a query for from the index 3 till the end of the segment tree. Here, please tell me about the sum of all of these elements. It is also gonna work in big O of login. So overall this append thing will work in login, and this g count thing can also be done in login time. So for the for loop of size n, the operations would be in login time, something like login time. So this for loop will overall take big of n login time. Now the part of actually implementing this data structure, like one thing you can do is just study about ordered set. After that, once you're done with the ordered set, this one is actually easy. After that, once you study about segment trees, the reason we actually use segment trees instead of ordered set is because ordered set are comparatively slower. These can have some bugs. You might someday encounter some bugs in them, and these are not really present in all the languages. Whereas this is something very reliable. It is present in all the languages, and it is very customizable as well, and it is faster. So study about this as well. It is a very useful technique. Now, once you would have actually studied about the technique, I'm 100% sure that doing this task is something you don't really need any editorial. You will be able to do it on your own, because once you practice, you would have actually solved problems which are harder than this one, which will involve things like updating in different ways as well. Basically harder. This is a subset of the problems which you would be solving, a sub problem of the problems which you would have solved while learning about segment trees with coordinate compression. So let me show you my code. This is a to do. Like this thing is, I'm leaving this thing to you as a to do to study about both of these things. After that, like you don't really need these explanations I gave you. Um, for the problem, for the problem specific part was only till this point. Till this point it was problem specific part, maybe this part as well, and after that forget about everything else. So my code here is, first of all, I created a segment tree. I wrote it during the contest, so it might not really look like a normal segment tree. I only wrote the things which I required to use for the problem. So this is why my template is looking very small. And yeah, this is an iterative segment tree. It is generally a little faster than the recursive one, and the code is pretty small. You can use your own segment. You can use your own segment tree template, create your own one, and use it. And for coordinate compression, the code is just as simple as this one. Here I created an array A, gave it all, like just copied all the values of nums into array A, sorted A, and then I created a function with name find, in which I will pass on a value and it will return me the index of that value inside the array A. So um, whenever I want to find out the value, whenever I want to find out the compressed coordinate, like after coordinate compression, whatever value there should have been for a specific element, I can just get it by calling this function find. I created two segment trees and two arrays, like for both of these. Wait a minute. Yeah, I created two arrays and two segment trees, basically one segment tree for both of these elements, and initialize the segment trees with n size. You would have already uh, done some things like this if you have actually practiced about segment trees with coordinate compression. Then, as I already knew that I would insert elements, like I will use this thing multiple times, so instead of writing it again and again, I just created a function with them insert, where I will pass on the index. Instead of creating ARR1 and ARR2 like this, I created an array so that I will be able to write a shorter code. Here I just pass on the index and then I can say ARR IND. Now if I pass up 0 or 1, on that basis it will take this thing. So I just got a smaller code because of this. If you want, you can just use if else conditions, it's up to you. um, I'm just like, if I have to insert a value at inside an array, I'm just pushing it back in the array, and in the segment tree for that array I'm adding one at the basically incrementing one at the uh, coordinate it should have. Like for this 7, it had a coordinate 3, so I'm like find of 7 will return me 3, and I will just go to 3 and increment it by 1. So that's what I've been doing here. And after that I'm having greater count, as it was being, like this was also being given to me. Since I knew that I would have to use it multiple times, I just created a function in which it will just return me the number of elements which are greater than x in the segment tree with index ind. Basically the first or the second segment tree, I will just pass on 0 or 1 on for my convenience, right? So that's it. It will return me the count, the number of elements which are greater than the given element x. Initially I had to insert 0 and 1 to the arrays, to the first two arrays, like to the arrays we had to insert the first two elements. After that I'm going on for each and every element in the array. I said that, hey, let x be the current element, just putting up the value into x so that I will not really have to write nums of I again and again. And here I said, here in case if the greater count of x is greater than the greater count of x, like for the array 1, if it is greater than, sorry, for the array with index 0, if it is greater than, the greater count is greater than for the array, the other array, in that case insert x into the array 0. Otherwise insert x into the array 1, in this case if the greater count for array 1 is greater. Otherwise If both of these are equal, then you come here and see here, in case if the size of the first array is less than or equal to the array size of the second array, then insert the element in the first array. Otherwise, insert the element into the second array. And at the end, I'm just concatenating both of them. You can use an STL function here if you like. Do it in any way you want. After that, I'm just returning answer. That's it. So I hope that the PCD helped you out. And if you liked the video, then please like the video. Like, if you like the explanation, then please click on the like button and you can consider subscribing to the channel. Thank you for watching the video, and bye bye.